In this video, let us discuss about physical and chemical changes. Chopping of wood versus burning of wood. Now, wood that we all know is predominantly made up of cellulose plus some other constituents. Now, whenever we chop wood, is block of wood, and if we chop it down, essentially we are just making it into smaller pieces. The chopped pieces can differ in their size and shape, but the composition is still the same. It is still made up of the same constituents, which is predominantly cellulose. Now, chopping of wood is considered a physical change as you are just breaking it down into smaller pieces, but the molecular composition is still the same. Now, when we burn wood, this becomes a chemical change because burning of wood would give carbon dioxide gas into the atmosphere, smoke, and ash. Now, this is basically a chemical reaction because the components in wood are being broken down to release a gas called carbon dioxide. Now, the molecular composition has changed, and that's why burning of wood becomes a chemical change, while chopping of wood into smaller pieces is only considered a physical change. Another example. Now, when we take a ice cube from the fridge and keep it outside, you will notice that the ice will start melting, and after some time you would only see liquid water. Ice is the solid form of water, and it is also made up of the atoms hydrogen and oxygen in 2 to 1. So you have two atoms of hydrogen and one atom of oxygen in a molecule of water. Now, liquid water molecular composition is also the same. It has two atoms of hydrogen and one atom of oxygen. So, melting of ice is considered a physical change because the molecular composition of water is the same in both the solid as well as the liquid forms. Now, let's see another situation. When current is passed through water molecules, the water molecules will decompose to release hydrogen and oxygen gases. Now, if I were to write the balanced chemical equation, it would look like this. So, here we have water, which is the reactant, and when you pass electricity, the water molecule is going to break down into hydrogen and oxygen gases. Now, this becomes a chemical change because water is no longer water. It has broken down to give two new molecules, which is hydrogen and oxygen. So, melting of ice is a physical change, but breaking down of water to form two new molecules is an example of a chemical change. Let's look at some more chemical changes that we encounter in our everyday lives. Whenever we strike a matchstick or burn a candle or build a fire, we are actually seeing a combustion reaction. Propane, which is C3H8, burns in the presence of oxygen to form carbon dioxide plus water, and a lot of heat is also released in this process. So this is what happens in a combustion reaction. When propane is burnt in the presence of oxygen, propane gets converted into a gas, which is carbon dioxide and water. Now, this also classifies as a chemical change because the chemical composition of the reactants have now changed. We no longer see propane on the products and it has broken down. The chemical identities of the molecules have changed, and so are their properties. So, combustion also classifies as a chemical change. Another common example that we see is Neutralization. So as we all know, in a neutralization reaction, acid combines with a base to give rise to a salt plus water. Now, if you take a classical example, hydrochloric acid combines with a base which is sodium hydroxide to form sodium chloride, which is our table salt, plus water. Now, this is the chemical reaction that takes place in a neutralization reaction. Acid combines with a base to form a salt and water. Now, neutralization reactions also come under chemical change. The products of the reaction, salt and water, they do not retain the acidic or basic properties of the reactants, and this is what makes it a chemical change. Another common examples for physical changes include vaporization or boiling, where a molecule converts from a liquid to a gaseous phase. Now, in the liquid water example that we saw earlier, if we were to boil water, then water molecules will escape from the liquid to the gaseous phase, which is called the water vapor. Now, in both the cases, the chemical identity of water remains the same. It is still containing 2 atoms of hydrogen and 1 atom of oxygen. So boiling or vaporization also comes under a physical change. Similarly, the opposite of boiling, which is called condensation or condensation of water vapor, in which a gas gets condensed back to its liquid form, is also an example of a physical change. Freezing, where a liquid converts back to its solid state. For example, water going from liquid to ice form, which is called freezing, also classifies as a physical change. Now, in all these cases, there is only a change in the state of the matter, but not the chemical identity of the molecules. Similarly, breaking of bricks, cutting of metal wires, or even bending of iron rods. So iron is a metal, so bending of metal rods like iron also classifies only as a physical change because the bent form is also having iron. It's only that its shape has been changed. So all these are examples of physical changes in our everyday life. Now, coming to chemical changes, some of the key signs that come with a chemical change include a change in the color, a change in the odor or smell, or even a change in the temperature. Now, in the combustion reaction that we have seen before, because it's an exothermic reaction, a lot of heat is released in the process. A lot of heat is released in the process, and this becomes a chemical change because most of the times chemical changes are associated with changes in the temperature of immediate surroundings. Okay, so cooking, burning, rusting. As we all know, iron will rust to form iron oxide. So there is a change in the color. There is a change in the color. So rusting of iron and even rotting are all examples of a chemical change. Okay, so some of the common signs that we can observe if a chemical change has taken place or not include changes in the color of the products, changes in the smell, or most likely a change in the temperature of the surrounding environment. So all of these come under chemical changes.